right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this week we focus on loops, this ability in Python and a lot of other programming languages to do something again and again, a cycle of sorts. And let's see if we can't begin by motivating exactly why we have this ability to do things cyclically using these loops. I'm going to go ahead here and open up VS Code. And in my terminal window, let's go ahead and create via code cat.py, a Python program that meows like a cat. And I'm going to go ahead here in this code tab. Very simply, perhaps, I'm going to start by implementing this cat just by using print. We're going to have this cat not make audible sounds, but just print meow, meow, meow on the screen 3 times. Well, I think the simplest way I can do this is just to print meow once, and to print meow again, and to print meow one last time on the screen. And now let me go down to my terminal window. Let me run Python of cat.py, enter, and meow, meow, meow. All right, so this program works. This program indeed works if my goal is to get the cat to meow 3 times. And let me propose, just to help us wrap our minds around what's going on inside of the computer, let me propose that we consider this flowchart. So as before, we have this flowchart that starts with a this oval, which just means start reading here. And then notice it goes via arrows to a meow, 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 and then it stops. It's perfectly correct, and honestly, it's wonderfully simple, but I dare say we can find fault with my code nonetheless. Why is my code arguably poorly designed? Now, the answer is going to be loops in some way, but let's see if we can identify in what way the code is actually poorly designed in some sense. Let's see. Any thoughts, Alex?
Okay, so I mean, repeating the same action like 3 times or even more is not a good
Yeah.
habit.
Yeah, I'm just repeating myself. And honestly, it's not that big a deal. If we go back to my code here, am I really doing such a bad thing by just printing meow, meow, meow 3 times? Not really, but let's consider the logical extension of this. Suppose I wanted to meow 4 times, or 5 times, or 50 times, or 500 times. Do you really think, even if you've never programmed before, is the solution to this problem really going to be to hit copy paste 50 times? Like, probably not. We can probably do better than that. And beyond it just being ugly at that point, having so many lines of identical code, just imagine if you wanted to change the code. Maybe I changed my mind and I don't want to make a cat, I want to make a dog. So now it has to say woof, woof, woof multiple times. Now I have to change that in like 50 different places. And yeah, sure, I could do find and replace, but come on. Like, we're programmers now. There's got to be a better way than just repeating ourselves. So I bet we can do better than that if we think about a little harder how we go about structuring this program. And we can do that if we augment our vocabulary just a little bit. It turns out in Python, and in other languages too, there's a keyword called while. And while is one way that we can express what's called a loop, a block of code that's going to do something again and again and again, 0 times, 1 time, 2 times, 50 times, as many times as we want. But while rather leaves to us the particulars of how we express ourselves to do something again and again. So let me go back over to VS Code here, and let me propose that I do this. While is a construct that allows me to ask a question again and again. And anytime we've seen a question, it's been in the form of a Boolean expression, a question to which the answer is true or false. Well, how could I do this? How could I print out meow 3 times and ask 3 times a question to which the answer is true or false? Well, what if I did some counting, right? Like literally on my fingers. And if I'm trying to count maybe down from 3, I want to meow 3 times. I can put 3 fingers up and I can meow. And then I can put like 1 of the fingers down and then meow. And I can put 1 of the fingers down and I can meow, put 1 of the fingers down. And maybe the question I can ask every time I meow is, do I have any fingers up still? Do I have any fingers up still? Do I have any fingers up still? And if the answer is true, keep going. If the answer is false, stop. So how can I translate that to code? Well, once we've added this while keyword, I think we have all of the building blocks already. Let me propose that I do this. Let me propose that I give myself a variable. And I'll call it I for integer, but I could call it anything I want. And I'm going to initialize it to 3. Then I'm going to use this new feature of Python, while, and I'm going to ask a question, the answer to which must be true or false. And I'm going to say, while I does not equal 0. So I'm going to ask the question, while I does not equal 0, do the following. Notice the colon at the end of the line. Notice my indentation. And just like with functions, just like with conditionals, you indent the lines that you only want to execute as part of this other thing. What do I want to do while I does not equal 0? Well, I think I just want to meow. But it's not enough just to write this code. If I were to very dangerously run Python of cat.py and hit enter right now, what might happen on the screen, whether you've programmed before or not? Why is this a very bad thing potentially? It's not going to break things, but it might lose control of my computer somehow. Any thoughts? Yeah, Timo?
Hi, I think it's going to continue to print out mail since I is always equal to 3 and the while is always true.
Yeah, exactly. If I'm initializing I to 3, that is setting it equal to 3 on line 1, then I'm asking the question, while I does not equal 0, and that's going to be true. It does not equal 0. It obviously equals 3. Print meow. And the way a while loop works is that the Python interpreter just keeps going back and forth. It goes from line 1 to line 2, then to line 3, and then it goes back to line 2 to ask the question again. If the answer is still true, it goes to line 3. It then goes back to line 2. If the answer is still true, it goes back to line 3. And to Timu's point, if you're never actually changing the value of I, it's always 3, you're just going to be looping literally forever. And this is an accidental infinite loop. So we've got to be smarter than that. And I'm not going to hit enter because I don't want to lose control over my computer here such that it's printing out meow forever. Fortunately, if you ever do that and you find yourself in an accidental infinite loop, Control-C for cancel or interrupt is going to be your friend. If you ever seem to lose control, you don't need to like reboot or turn off the computer. You can just hit Control-C in your terminal window, and that will likely fix it. All right, well, what do I want to do then after meowing each time? I think what I'd like to do here is maybe something like this. Let me update I to equal whatever the current value is minus 1 here. Whoops, sorry, minus 1. So if I, on each iteration, am updating I to be 1 less, 1 less, 1 less, it should eventually hit 0, at which point the answer to line 2's question will now be false. So let's see if this works. I'm going to go down to my terminal window and run Python of cat.py, and I indeed get 3 meows. Why? Because I've kind of wired this up, kind of like a machine in software, if you will. I've set I equal to 3, then I keep asking this question. But I keep turning the gears. I keep changing the value of the variable to make sure that ultimately it is actually being decremented, that is, decreased by 1 until we eventually hit 0. Now, for those of you who think a little more graphically, let me pull up one of our usual flowcharts. This is just a representation graphically of the exact same thing. Notice what's happening. I first start the program, and then I initialize I to 3, and then I ask the first of my questions. Again, the diamonds always represent questions, and the answer is going to be true or false. Does I not equal 0? Well, it doesn't. It equals 3, so if I follow the true line, I meow. And then I follow this arrow, and I update I to equal I minus 1. At this point in the story, I presumably equals 2 mathematically. I follow the arrow, and there's the loop. This is why it's nice to see this graphically, perhaps, because you can literally see the loop back and forth. Now I ask the question again, does 2 not equal 0? Well, it does not equal 0. It's 2, so we meow again. We change I from 2 to 1. Well, does 1 not equal 0? Well, obviously, 1 is not 0, so we meow again. We decrement I again. I is now 0. Does 0 not equal 0? No, it equals 0, so the answer is false, and we stop. So there, perhaps more so than any of our flowcharts before, do you really see the structure of what's happening inside of the program? And you don't have to get into the habit of making these charts or creating these charts, but just as a first pass at what's going on inside of the computer, that's indeed one way to visualize it instead. Well, let me propose that, like always, there's many different ways to solve this problem. And suppose you just like to think a little differently. Maybe you don't like starting at 3 and then counting down to 0. Why? Maybe your just brain doesn't work that way and you prefer to count up instead of down. Totally fine. Let me go ahead and change my code here to set I equal to 1 instead of 3. And here, let me just change my logic. Rather than checking for not equal to 0, like maybe you don't like thinking in terms of not because it's a little confusing, and it might be. Let's just check that I is less than or equal to 3. So we'll be a little more explicit. We'll count from 1 up through 3, each time printing meow, but I'm going to need to change this line here. Let me see if we can't call on someone to change line 4 for me. How do I want to change line 4? To be consistent with counting from 1 up to and through 3.
I would be +1 every time you meow.
Yeah, exactly. In this case, we want to add 1, not subtract 1. And in fact, if you think about this, this too could end very poorly, right? If you start counting at 1 and you keep subtracting 1, subtracting 1, subtracting 1, I think we're going to find ourselves with the same problem, which is that we're never going to stop because we're going to keep getting more and more negative as opposed to ever getting up to the number 3. So I think you're right. I need to change this to be I equals I plus 1. And now notice, just for clarity too, the equal sign is, again, our assignment operator from right to left. Logically, this might otherwise strike you as strange. Like, how can I equal itself plus 1? Well, it doesn't until you execute this code from right to left. You add 1 to I, or you subtract 1 from I, and then you update the value of I on the left. The assignment copies the value from the right to the left. Well, how else might I do this? Well, I will say that most programmers, computer scientists more generally, tend to start counting from 0. It's a convention, and it actually has upsides even in Python and other languages where, generally speaking, it's a good thing to start counting from 0 instead of counting like we might in the real world from 1. Let's go ahead and adopt that convention now. Let me set I equal to 0, and I need to make a change now. Notice, if I don't change my logic, this program just became buggy. The cat has a bug. It's now meowing 4 times if I run it as is. But the easiest fix here would be to change my inequality to be this, less than, instead of less than or equal to. Now, I'm starting at 0, but I'm going up to, but not through 3. And even though this might, of all the things we've seen thus far, seem maybe the least familiar, most of us might start at 1, 2, then 3. It's a good habit to get into now. Start at 0 and go up to, but not through the value that you care about ultimately, 3 in this case here. Well, let me tighten things up a bit here. Not only will this now fix my counting problem, it now meows 3 times as expected, there's a more succinct way to express I equals I plus 1. And this is because it's such a popular thing to do in code. You can instead just say I plus equals 1. And that's it. You don't need to put everything on the right-hand side. This is a special syntax that says the exact same thing, increment I, but it does it with a few fewer keystrokes. It's just a little more pleasant to type. It's a little faster to read. It's just a convention. Those of you who have programmed in C, C++, not Python, C, C++, Java, JavaScript might have seen plus plus before or minus minus. Sorry, Python doesn't have it. So you cannot use that. This is as succinct as your line of code might get. All right, let me pause here to see then if there's any questions about these implementations of while loops.
Can we use stuff like for loops, which have a certain I value initialized to it at the start, and it runs from the particular condition you put into the thing and increment it as you go along?
Short answer, no. You cannot do what you're describing, but there is another type of for loop that we will soon see. But let's come to that in just a moment. Other questions on loops using while here?
So I had a question about the flowcharts.
Okay.
There were certain symbols for the certain kind of the statements. So are they certainly used for that kind of statement that they are put there?
They are. So
I deliberately use anyone.
I deliberately use certain types of symbols, certain shapes here, whereby an oval is conventional for start and stop. I used rectangles for any statement of code, like an assignment or a printing and so forth. And I used diamonds to represent questions that you might ask, conditions, as we've seen. If you're doing this for yourself, if you're just trying to make sense of your code and writing it down, you certainly don't need to use these formal symbols, but I tried to be consistent with some best practices. And in fact, let me come back to this same picture because this was the first version of our picture, but we've since modified our code a couple of times. This, recall, was the version where the question we were asking was I not equal to 0. Let me go ahead and just change this code now to represent the next version we did, which, recall, changed our logic to start counting from 1. It changed our question to check is I less than or equal to 3, but then everything else was the same except for the counting, which is now plus instead of minus. And then we refined it a little bit further by counting now from 0 up to, but not through 3. And we tightened up this code here by just incrementing 1 by using the slightly more succinct syntax. So at this point, these flowcharts might become less and less useful for us because once you've wrapped your mind around the concept, and hopefully the picture helps bring that concept to life, it's certainly fine to focus entirely on the code and only think about or even draw something like this if you need to wrap your mind around something more complicated than you're used to. Well, let me go ahead, if I may, and propose that we transition to another approach of types of loops using another keyword here, namely a for loop. And this is a word that does exist in other languages, but doesn't necessarily have as many features as other languages might use it for. But there is a different type of loop, not a while loop, but a for loop. And a for loop is going to allow us to express ourselves a little differently. But to do so, I'd propose that the easiest way is if we introduce one other idea in Python, which is that of a list. And here, too, no pun intended, we're adding to the list of data types that Python supports. We've seen strs or strings, ints or integers, floats or floating point values, bools or Boolean expressions. Python also has lists, which is another type of data. But wonderfully, this one's probably pretty familiar. A list of things in the real world is a list of things in Python. It's a way of containing multiple values all in the same place, all in the same variable. So what do I mean by this? Well, let me propose that we go back to our VS Code here, and let me kind of start fresh with my code here and not use a while loop at all, but let me use this new keyword for. The way the for loop works is that it allows you to iterate over a list of items. So what does this look like? It might look like this. For I in the following list of items, 0, 1, 2. This is my starting point, and on each iteration of this loop, that is, on each execution of this loop, again and again, I want to print out meow. Now, I'll admit, I kind of like the look of this code already, even though there's some new syntax here, because it's just shorter than the while loop, right? The while loop had multiple lines a moment ago, and it was entirely up to me to decide what I is. I have to check a condition. I have to increment or decrement I. Like I was doing a lot of work, relatively speaking, to make that thing turn, to make that loop go and to go. It was very mechanical in a sense. You can kind of, in your mind's eye, maybe see the gears turning as all of these variables are changing and these questions are being asked. A for loop kind of simplifies all of that. And it just says if you want a variable, like I, a number, and you know in advance how many times you want this loop to execute, 3 times, we'll just kind of specify what it is you want I to take on as values explicitly. In this loop, I will be automatically initialized by Python to be 0. Then meow will be printed. Then Python will automatically update I to equal 1. Then meow will be printed. Then Python will automatically update I to be 2, and meow will be printed. And because that's it for the values in that list, Python will stop, and it will only meow a total of 3 times. What is the list? The list in this program is exactly that, 0, 1, 2, and notice the square brackets. Those aren't parentheses. Those are square brackets that represent a list. That's how you know visually as the programmer. That's how Python knows as the language that you intend for that to be a list. So let me go ahead and run this, Python of cat.py, and it works just the same. But it's only 2 lines. It's pretty readable once you have familiarity with that construct. But to my constant point about correctness not necessarily being the same as design, in what sense is this program perhaps poorly designed? It seems to work. It meows 3 times. But why might this not be the best way to solve this problem? Even if you've never programmed before, again, think about corner cases, things that may or may not happen. Think about extreme cases that really test the quality of this code.
Okay, I think that because like we are saying 0, 1, 2 3 times, and then like if you want to print a million, you say 1, 2, 3.
Yeah, exactly. And that's what I mean about thinking about the extreme cases. If you're trying to decide for yourself if your own code is good or someone else's code is good, it might look so at first glance, but think about the extreme. Well, what if it's not 3 things? It's a million things. I mean, are you really going to write out 0 through a million or 0 through 999,999? Like, no, you're not going to write that many numbers on the screen. There's got to be a better way. So let's do the better way from the get-go rather than set the stage for doing something poorly. And the one way we can solve this problem to improve the design is don't just manually specify the list of values. Use a function, someone else's function that comes with Python that gives you the list you want. And the easiest way to do that in Python is to use a function called range that returns to you a range of values. It expects as input at least one argument, and that number is going to be the number of values you want back. Those values are going to start at 0 and go to 1 to 2 and so forth, but they will go up to but not through the number you specify. So by specifying range 3, you're essentially being handed back 1, 2, 3 values. And by default, those values are 0, 1, and 2, and that's it. But what's brilliant about this is that now, to Hope's point, if I do want to meow 1,000,000 times, I mean, that is an angry cat, I can now do 1,000,000 by just typing 1,000,000. I don't have to literally type 0, 1, 2, 3, 4, all the way up to 999,999. I just do this. So that's got to be a better way long term. So that's indeed one improvement we can indeed make here, still using a for loop, but now using this range function. And just to show you something else that's Pythonic, this is not strictly necessary, but it's commonly done. There's a minor improvement we can make here, even if we're just meowing 3 times. And notice that even though I'm defining a variable I, I'm not ever using it. And it's kind of necessary logically, because Python presumably has to use something for counting, right? It has to know what it's iterating over. But there's this convention in Python where if you need a variable just because the programming feature requires it to do some kind of counting or automatic updating, but you, the human, don't care about its value, a Pythonic improvement here would be to name that variable a single underscore, just because. It's not required. It doesn't change the correctness of the program, but it signals to yourself later, it signals to colleagues or teachers that are looking at your code too, that yes, it's a variable, but you don't care about its name because you're not using it later. It's just necessary in order to use this feature, this loop in this case here. So just a minor improvement or change there. But to really get you intrigued by what's possible in Python, let's take this one step further. So if we really want to be Pythonic, this one, if you've programmed before, is kind of going to blow your mind, so to speak, whereby if I want the cat to meow 3 times, what if I actually do this? Print, open parenthesis, quote unquote, meow times 3. All right, you have to be kind of a geek to think this is cool, but this is kind of cool. So you can literally just print what you want, multiply it by the number of times that you want it, and you will get back exactly that result. Now, I've kind of made a mistake here, so let's see what this does. It's not quite as beautiful as this code might look to you, to some of you, to me. Let me run Python of cat.py, enter. OK, it's a really like hungry cat or something. It's meowing really fast. But I can fix this, I bet. Let's think about now some of the basic building blocks we've discussed. The problem is clearly that literally meow, meow, meow is being repeated 3 times, but it's not as pretty as I want it. I want it to be meow, meow, meow on separate lines. What might be a possible solution here while still using this multiplication operator? And think back, we've used plus to concatenate strings. You can apparently use multiplication to concatenate strings, but more than once, again and again and again. How could I clean this up without reverting to my for loop or my while loop and still use multiplication in this way?
We can use the escape sequence, which should be \n.
Amazing. Yes, think back to \n, which is the way you as the programmer can express a new line in code. And I think if I take your advice, I put a \n there inside of my quotes so that at the end of every MEOW, there's a new line. Let's see how this looks. Let me clear my screen and run Python of cat.py. OK, so close. I like this. Let me call on someone else. The only thing I don't like, and I know I'm being really nitpicky now, is that it's meow, meow, meow on separate lines, but there's kind of this extra blank line, which I'm just not loving aesthetically.
I think we can make end equal to colon, not backslash n.
Yeah, so here too, like all of these things we've seen in past weeks are kind of coming together, right? Recall that the print function lets you control what the line ending is. By default, it's \n itself, which is why at the very end of this print, the cursor is being moved again to the next line. Well, we need to just override that. So let me go into my code here, and let me change this to comma end equals quote unquote, so that it's no longer the default \n. It's instead now going to be nothing whatsoever. That should eliminate then hopefully that additional blank line. So let me run this one last time here, python of cat.py, enter, and there we have it. So now, you know, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got end equals quote unquote. So you don't have to do things this way. My previous approach with a for loop, totally fine. My previous approach with a while loop, totally fine, and in some sense, perfectly well designed. But this is just yet another way to do it, but it's not a good thing if you or your teacher, your colleague, your friend are going to struggle to read your own code. But this is a feature of Python that some languages do not, in fact, have. All right, well, let me propose that things get more interesting still if we're not just meowing 3 times only, but we're meowing some variable number of times. Let's ask the user how many times this cat should meow. So let me clear the screen here, and let me figure out, well, how do I get a number from the user? The catch here is that if I want the user to give me a number, I'm not doing math per se, I'm meowing, and therefore the user has to give me a positive value. The user has to give me a positive value. So how can I insist on this? Well, if I just do this, n equals int of input, what's n, question mark. Well, I want to check, like I could say if n is less than 0, like if it's negative, well, I could do this. Well, then ask again, int input, what's n, question mark. OK, well, what if the user still doesn't give me a positive number? What if they're being really difficult, they're not paying attention, and they typed in 2 negative numbers? Well, if n is less than 0, well, let's do it again. N equals, right, this does not end well. You can't infinitely many times keep checking, is it negative, is it negative, is it negative, right? The program would never be done written. So we can do this, I think, better maybe with a loop. So let me propose this, a very common paradigm in Python when you want to get user input that matches a certain expectation you have, that it's all positive, that it's all negative, or just something like that. You just immediately say while true. You deliberately, and a little dangerously, but very conventionally, induce an infinite loop. Now, what is an infinite loop? It's just one that goes forever. And we've seen how that can happen accidentally, mathematically. It's absolutely going to happen when you say while true. Why? Well, the answer to the true question is always true. So this is a way of deliberately inducing a loop that by default is going to go forever. So we're going to need a way of breaking out of this loop when we have the number we want. The convention, though, inside of this otherwise an infinite loop is to ask the question you care about, like give me an int by prompting the user for input, like what's n, question mark, and then just ask your question. So if n is less than 0, then I think we want Python to just continue to prompt the user again. That is, we want the code to stay in the loop, recall the input function, and hope that the user gives us a better answer if this time around it's less than 0. So let's just literally use Python's keyword continue, which says just that, continue to stay within this loop. Else, if it's not less than 0, let's go ahead and just break out of the loop altogether using another keyword in Python, break. Break will break you out of the most recently begun loop, in this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user, but I think we can tighten it up further so as to not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0, so let's wait until they give us an integer that is greater than 0, and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before. And let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like, I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start with 3, where we began, meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py. Let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm in Python when you want to do something again